Visual inspection is carried out by observing whether the latex glove inflates, indicating the presence of air leakage. If there's a small hole, the glove inflates very slowly.
If there's always excess pressure on the product side, then in the event of a leak, we'd constantly be contaminating the heat transfer medium.
Okay, Sergey, let's move on to the next method, the air test.
Yes, the next method is the air method. The working principle is that one of the heat exchanger's circuits is sealed, and a latex glove is placed over the outlet port. The second circuit is pressurized with compressed air at a pressure ranging from 0.3 to 0.6 megapascals. This pressure is maintained for 10 to 30 minutes, after which a leak check is performed. Visual inspection is carried out by observing whether the latex glove inflates, indicating the presence of air leakage. In other words, it checks for internal leaks within the heat exchanger if any exist. Commonly, this method is referred to as the glove test, because a simple latex glove placed on the circuit clearly shows whether it inflates or not, indicating the presence of a potential leak. The key advantage of this method lies in its simplicity, accessibility, and ease of implementation without requiring specialized equipment. That is, it requires minimal preparation and takes even less time compared to the hydraulic method. There's no need for any liquid, only air is used. And since compressed air is available at almost every facility, the method is easy to implement across a wide range of industrial environments. Disadvantages: limited accuracy, meaning this method doesn't detect microcracks either. Labor intensity: the process can take time for accurate leak detection. Test time: you have to wait a long time for results. If there's a small hole, the glove inflates very slowly. And in terms of accuracy, it doesn't show the exact location of the leak, just whether it's there or not.
Sergey, my first question for you. Could you tell us, what's the main advantage of this method compared to the hydraulic one? Because essentially, the only difference is the medium we use for testing the heat exchanger. So what makes the air method more convenient?
Basically, you don't need any liquid for the test. Just hook up the air, and that's it. You pressurize the heat exchanger to the required level, and you're done. That's the simplicity of it, and the main difference from the hydraulic test.
All right, Igor, a question for you. When comparing the air method, using air as the testing medium, with the hydraulic one, what are the key differences or things to keep in mind? What types of damage does the air test allow us to detect? I know there are more advanced versions of the air test. Could you briefly comment, in your opinion, what's the real difference? Are there any actual advantages of using air instead of hydraulic testing?
From the user's point of view, I don't actually see much of a difference between hydraulic and air testing. As you rightly said, instead of a glove, you can use a pressure gauge, a manometer, which lets you detect even slight pressure changes more clearly and in a smaller range. That definitely boosts accuracy. But overall, for the user, again, I don't think there's a big difference between the two methods.
All right. We also had an internal discussion about the fact that many companies, especially in practice, support the use of differential pressure, right? Meaning they pressurize one section more than the other to check for leaks using that pressure difference. It's another common variation of the test. But there are also companies that believe if you maintain higher pressure in one of the circuits, especially in the one carrying the pasteurized product, then even if there are small cracks or openings, it prevents overpressure or backflow from the unpasteurized side or the cooling medium into the final product. Thus, by maintaining higher pressure in the product section, we can ensure the safety of the final product. Igor, what's your take on this approach? How do you view this practice?
In fact, this is standard practice in all the companies I've worked with. But it can't be considered a control measure that guarantees the product won't be contaminated. Rather, it's part of good manufacturing practices. One of the prerequisite programs needed to maintain a hygienic production environment. And that's why leak tightness testing of heat exchangers and their regular maintenance should go hand in hand with pressure difference control. It should also be noted that if there's always excess pressure on the product side, then in the event of a leak, we'd constantly be contaminating the heat transfer medium, thereby increasing the risk of cross-contamination elsewhere in the production process. And finally, it's important to mention that during transitional phases of production, like startups, shutdowns, or switching between cleaning and product, there are always pressure fluctuations that are hard to control. So if the heat exchanger has leaks, contamination can easily happen during these moments, potentially leading to product spoilage. That's why monitoring the integrity of heat exchangers is absolutely essential. Just controlling the pressure difference alone, without checking for leaks, won't protect us.
Thank you very much. And about the air test, Sergey, I've got a practical question for you. As far as I understand, the traditional way to perform this test is by putting a glove on the outlet of one of the sections we're checking, right? As far as I understand, the glove is held for some time, and then you watch to see whether it inflates or not, because if the leak is small, it probably won't show up right away. Can you tell us, does the temperature of the heat exchanger, like whether it's cooled or not, and the air humidity, do these factors influence the result? I mean, when doing an air test, can you really expect accurate results, or do the testing conditions matter a lot?
Yes, you definitely need to take the conditions into account, because the test should be done in an environment that's as close to real production as possible. Same temperature, same humidity in the room. That's what gives a more accurate result.
Thank you.